Today, we're talking about a medical revolution, one that began with a machine born from a 7-year struggle and is now being completely reinvented by artificial intelligence.
I mean, think about it. It's the fundamental challenge of medicine, right? How do you find what's wrong deep inside someone's body without actually having to open them up? And while the answer today is increasingly AI, that's not where the story starts. See, before we could teach a computer how to predict a disease, we first had to teach a machine how to see it. And that story begins with one doctor and a very personal mission. Okay, so it all kicked off with an idea that, at the time, was truly revolutionary. It would literally change the way we see ourselves. This is Dr. Raymond Damadian, and for him, this wasn't just some abstract scientific problem. He was haunted by the memory of his grandmother's death and was dead set on finding a better, non-invasive way to spot cancer. He had a hunch that the answer was hiding in a field called nuclear magnetic resonance, or NMR. So Damadian's big idea was this. Our bodies are mostly water, and the protons in that water act like tiny microscopic compass needles. If you hit them with a powerful magnetic field, they all snap to attention and line up. But the real key, the insight, was what happens when you turn the field off. He bet that the time it took for those protons to relax and go back to normal would be different for healthy tissue and cancerous tissue. And you know what? In 1971, he proved he was right. He published this incredible paper in the journal Science showing that cancerous tumors in rats had much, much longer relaxation times than healthy tissue. That was the aha moment. That difference created a contrast, a signal you could pick up on. It was the very first step toward what we now know as the MRI. But look, going from a discovery with lab rats to an actual machine that could scan a whole person, well, that turned out to be a massive, monumental struggle. It took Damadian and his small team of grad students 7 years. 7. They built the machine by hand, teaching themselves how to weld and machine parts along the way. They fittingly named it Indomitable, because that's exactly what they had to be to get it done. And then, finally, the big day came. July 3rd, 1977. One of his assistants, a guy named Larry Minkoff, bravely climbed inside this massive contraption. The machine scanned him, point by painstaking point, for almost 5 straight hours. And at the end of it all, they had it. The world's first full-body MRI scan. Now, let's be clear. The image was, well, it was rough, really basic. But that didn't matter one bit. What mattered was that Indomitable had worked. It proved that you could actually use magnetic resonance to see inside a living person's body. It was nothing short of a miracle. And this is where the story gets complicated. In 2003, when the Nobel Prize for the MRI was awarded, Damadian's name was left off. The award went to 2 other scientists, Paul Lauterbur and Peter Mansfield. Now, their contribution was huge. They figured out how to use magnetic gradients to make the images clear and fast. But Damadian's argument, and it's a powerful one, was that without his core discovery, that tissue contrast even existed, there would be nothing to make an image of in the first place. It's still a huge debate today. So Damadian's work literally opened our eyes to what was inside the body. But now that same basic idea is being taken to a whole new level by the next big thing in medicine, AI.
This is the new way of thinking. It's not just about a doctor looking at a scan anymore. With AI, we're building predictive models of the body. The AI can simulate what it thinks should happen, compare that to the real data from a patient, and learn from any differences. It's a constant, dynamic feedback loop that gets smarter with every single patient. And here's the really crucial shift. Damadian's breakthrough was teaching a machine to see physical differences, those relaxation times. Today's revolution is about teaching a machine to see patterns in data. We're talking about patterns so complex, so subtle, that they're totally invisible to the human eye. And the results are just wow. This chart shows the difference between regular machine learning and the more advanced deep learning. You can think of it like this. Machine learning needs a human to guide it and help it improve. Deep learning, it can teach itself, finding patterns we didn't even know existed. And as you can see, that self-teaching ability makes it incredibly powerful and accurate. And this isn't some far-off future stuff. It's happening right now. AI is already outperforming human experts at specific tasks all over the place. We're seeing it find tiny tumors in mammograms, predict heart attacks in the ER, and even diagnose Alzheimer's just by analyzing MRI scans, the very technology Damadian pioneered. The applications are just exploding. But just like the invention of the MRI, this amazing new AI revolution comes with its own set of pretty serious challenges and controversies.
So we have to ask ourselves, right, as we rush headfirst into this new world, are we just setting ourselves up for the same old fights about credit, control, and ethics, just with newer, fancier technology? You know, it's pretty amazing how perfectly the challenges of the past mirror the challenges of today. The human conflict over the Nobel Prize. Today, we're talking about algorithmic bias, a conflict that's literally baked into the code. The patent battles over who controlled MRI technology. Today, it's all about who controls our personal data. And the early arguments over whether MRIs were even practical? Well, now we're arguing about whether we can trust a black box AI to make life or death decisions. And that issue of data and trust is a really big deal. A survey in the UK found that almost 2/3 of people were not comfortable with their personal health data being used to train AI systems. And think about it. If people don't trust the system enough to share their data, the whole thing grinds to a halt. And here's maybe the scariest part. Bias. An AI is only as smart as the data it learns from. So if most of the data comes from one demographic group, the AI might not work as well for everyone else. It could accidentally make healthcare less fair, not more. And that's not a bug you can just patch with code. It's a reflection of the biases in our world. So after all that, where are we headed? What is the real ultimate promise of this completely new way of looking inside ourselves? Well, if we can get it right, the future is incredible. We're talking about medicine that's personalized right down to your DNA. We're talking about technology that doesn't just find a disease you already have, but predicts you're going to get it years from now. It's a future that's more accurate, more accessible, and hopefully more fair for every single person. In the end, Damadian's indomitable machine gave us a window into the present. It showed us the what is. But AI is promising to give us a glimpse of the what will be. The only question left is, as we get closer and closer to knowing our own medical futures, are we actually ready for that knowledge?